Hello, my name is Jagger Kochi, and in this lab interactive presentation, we'll be talking about nuclear bombs and how their reactions occur. But before I dive into the details of how that works, I think it's important to state that there's two different types of nuclear weapons, or I guess we'll call them bombs. One is just obviously the nuclear bomb, which an example of this would be the atomic bomb, which contained uranium-235 that was dropped on Hiroshima. And then the other one is a hydrogen bomb, which hydrogen is just based off of thermonuclear components. And an example of this would be the Tsar Bomba, which is actually the largest hydrogen bomb that was ever created. So for nuclear reactions to occur, first of all, a certain reaction must occur between the fission of heavy nuclei, which examples of heavy nuclei would be like the uranium, which I'll get into that more here in a second. But first, nuclear fission is a reaction in which the nucleus of an atom splits into two or smaller nuclei. So the way I kind of like to think about this is, I was a big SpongeBob kid growing up. In an episode, Plankton, he somehow just gets the hold of just a single atom, and he just splits it apart, and then everything around him just blows up, combusts in his face. So I kind of like to think of it like that, just to kind of tie it in to see what it would look like, because obviously I've never seen a nuclear reaction go off in my life, and I don't ever want to be a part of that. I don't wish that upon anybody, because these are like real deal, like planet wiping weapons if they're not used properly or effectively, and there needs to be a lot of safety components that go in with this. But to further go on into these heavy nuclei, an example of this is like the uraniums, like I said. And uranium is actually an isotope, and isotopes are distinct from nuclear species of the same element. So again, back to uranium, you have different types of uranium. You have uranium-235, uranium-238, excuse me, and you have uranium-234. But uranium-235 is the only one out of these isotopes that is capable of triggering this nuclear reaction or explosion to occur. And in order for the blast to occur, there must be inside of the bomb, whether it be like in the video example, whether it be that small ball or like the torpedo-shaped missile, it needs to be at least 80% of uranium-235 components in there. Excuse me, I'm sorry. And then the nuclear explosion occurs because a certain mass of fissile material is concentrated into one place. So just imagine something very, very tiny, and it's just being concentrated on in one place, and this is called a critical mass. And for a nuclear explosion to occur, one critical mass is not enough. In the video, it stated you need at least 4 to 5 different critical masses, which is absurd. That is just an absurd amount of destruction levels of explosions of the TNT. It's absurd. It's almost inconceivable how much energy that is. But whenever the critical mass is reached, a nuclear decay reaction is formed with the release of energy. And so that is how the explosion occurs, is because of that powerful energy. Excuse me, I'm sorry. But then essentially also there's forces that are being harnessed that hold the nucleus of an atom together, that use the energy is released into the particles of the nucleus, which is the neutrons and the protons. And again, these things become split. This is going back into the nuclear fission. So essentially the whole key of this reaction is just something being concentrated on into one tiny, tiny place, and then just having this split of an atom is the whole thing that triggers these reactions. But I found this very interesting, and again, it's very inconceivable to me with the amount of radiation that these bombs can also endure. There's 3 different types of radiation that these can cause after the bomb goes off, essentially. And you can't see or hear the radiation, but that's arguably the most destructive component about these weapons, is the aftermath of is the worst thing for it to happen. So that's just kind of a little rundown, a little overview of how this whole process is interacting and occurs. So thank you for watching. I appreciate it.